When you think of probability, what you're actually thinking about is theoretical probability. Theoretical probability is you have a 6-sided die, there's one way to roll a 1, so your probability of rolling a 1 is 1/6. So here's an example. What is the probability of rolling a 4? What would be the probability of rolling a 4? 1 out of 6. There's one way to roll a 4. There are 6 possible things that you could roll on the die. The probability of rolling an odd number. How many odd numbers are on a die? 3 of them. There's 1, 3, and 5. So that's 3/6, which simplifies to the fraction 1/2. You have basically a 50% probability of rolling an odd number. How about rolling a number less than 7? 6 out of 6, which is 1. Now, you can express probability as a fraction, a decimal, or a percent. So, a probability of 1 means you have a 100% probability of rolling a number less than 7. Here's the technical notation for probability. P of something. So the probability of something happening is the number of ways that thing can happen over the total number of things. Let's look at the CD player problem. You put a CD that has 8 songs into your CD player. You set the player to play the songs at random. The player plays all 8 songs without repeating any song. What is the probability that the songs are played in the same order that they are listed on the CD? There is one way for those songs to play in order, numbers 1 through 8. So 1 over something. That something at the bottom is how many ways are there for all 8 songs to play. So the first song that plays, there's 8 possible songs that could play. The next song, there'd be 7 possible, and then 6, and then 5, and then 4. Do you remember that from before spring break? 8 factorial. So plug into your calculator 8 factorial. I believe it's 40,320. So we have a 1 in 4,320 probability that the songs will play in the order that they were intended on the album. A card is drawn randomly from a standard 52 card deck. Notice the standard 52 card deck does not include jokers. Jokers do not have a suit or a color or a numerical value, so they are not considered part of a standard deck of cards. Jokers don't count. Do not count jokers. What is the probability of drawing a 7 of spades? How many 7 of spades are in the deck? 1. How many cards are there total in the deck? So 1 out of 52. What is the probability of drawing a diamond from the deck? 13 diamonds out of 52 total cards. Notice probability is the number of things that you want over the total. Now reduce that fraction. If you have a scientific calculator, 13 ABC button 52 equals, and it will simplify the fraction for you. If you have a graphing calculator, 13 divided by 52, push your math button, select to fraction, the first option, and it will simplify that fraction for you. This one simplifies to 1/4. Does it make sense that 1/4 of the deck is diamonds, so your probability of drawing a diamond is 1/4? A red face card. So take a look at that diagram and count up how many red face cards are there. There are 6 red face cards. There's the Jack, Queen, King of Hearts and Jack, Queen, King of Diamonds. There are 6 red face cards out of 52 total. Simplify that fraction. All right, I would like you to try D and E on your own. Now, to save some time in our notes, I am not going to simplify the fractions. I'm going to assume that you all know how to simplify the fraction. Your answers should be a fraction in simplified form. So make sure that you're writing yours as a simplified fraction. Okay, let's turn the page and look at experimental probability. A spinner has 5 sections colored red, green, blue, yellow, and purple. Each section of the spinner has the same area. The table shows the results of 50 spins. That's a very important piece of information. Make sure you circle it. Experimental probability has nothing to do with theoretical probability. Experimental probability is looking at, I'm going to do this experiment. I'm going to take this spinner and spin it 50 times, and here's the results of that experiment. I spun red 5 times, I spun green 20 times. Experimental probability uses this data. Experimental probability doesn't care what should happen. Experimental probability is simply what did happen. So, for experimental probability, we spun red 5 times out of 50 spins. The experimental probability is 5 over 50. What is the experimental probability of green? 20 over 50. And these can all be simplified. This one is 1/10. This one is 2/5. Now, let's talk for a moment about what the theoretical probability would be. There's 5 colors. What's the theoretical probability of spinning red? 1 out of 5. There's one way to spin red out of 5 possible things you could spin. So the theoretical probability for all of these is 1/5. Take a moment and find the experimental probability for the last 3. And then the question is, for which color is the experimental probability the same as the theoretical probability? If you want your experimental probability to be as close as possible to theoretical probability, your number of trials needs to be a very, very large number. If you want all of these to be approximately 1/5, instead of spinning 50 times, you would need to spin like 1,000 times or 5,000 times. The more number of trials you have, the closer the experimental probability will approach the theoretical probability. Compound events. The big thing that you need to know with compound events is that the word or means you add the probabilities together. Or means add. The important thing here is that the two things must be mutually exclusive. Mutually exclusive means no overlap. So if I ask you for the probability of drawing a diamond or a face card, there is overlap there because there are diamonds that are also face cards. However, if I say, what's the probability of drawing a spade or a heart? There are no spades that are also hearts. Those two events are mutually exclusive. So mutually exclusive means no overlap. And the probability of A or B occurring is the probability of A plus the probability of B. So here's an example. A card is randomly selected from a standard deck of 52 cards. What is the probability that it's an ace or a face card? How many aces are in a deck of cards? 4 out of 52. So the probability of selecting an ace is 4 out of 52. How about a face card? How many face cards are in the deck? 12 out of 52. It says or, so we add those together. 4 plus 12 is 16 out of 52. Remember, when you're adding fractions, you only add the numerators with common denominators. So try number 6. What is the probability that you draw a 2 or a 3 or a 4? The probability of the complement of an event. A complement is like the other half of the probability. For example, to roll a 1 on a standard 6-sided die, you have a 1/6 probability. To not roll a 1, you would have a 5/6 probability. So it's like the other half, the other side of the probability. And they use this symbol, probability of A prime, and you do a whole 1 minus the probability that something happens. So this first one is the most difficult. The probability of something happening is 0.5. Think of it like a percent. The probability that it happens is 50%. What's the probability of it not happening? 50%. If there's a 50% chance it's going to rain today, that means there's a 50% chance it's not going to rain. So I want you to think of this symbol as being the probability of not A. The complement is something not happening. If the probability that something happens is 4 out of 7, what is the probability of that thing not happening? 3 out of 7. It's going to rain 4 days out of this week. That means it's not going to rain 3 days out of the week. A card is randomly selected from a standard deck of 52 cards. What is the probability of not getting a 10? Thinking about the complement is often easier than thinking about the actual event. So the probability of getting a 10 is 4 out of 52. There are 4 10s in the deck. So think about the whole deck, 52. What is 52 minus 4? So the probability of not getting a 10 is 48 out of 52. This is where thinking about the complement can actually make your life easier. What is the probability of when you roll 2 6-sided die, what's the probability that the sum is not 8? That'd be a lot to try to count up. So instead, I'm going to look at this chart and think about what is the probability that the sum is 8. So if I look here, 6, 7, 8, there's 8, 8, 8, 8, 8. There are 5 out of 36 where the sum is 8. So now subtract that from the total. What is 36 minus 5? 31. So the probability that the sum is not 8 is 31 out of 36. And that's what you're actually trying to find in that problem. What is the probability that the sum is greater than or equal to 4? Well, here's a sum of 4, here's a sum of 4, here's a sum of 4. And the rest of these would all have sums greater than 4. So really, how many outcomes have a sum less than 4? 3 of them. So take 36 minus 3, that'd be 33. 33 out of 36. The probability that you would get a sum greater than or equal to 4 is 33 out of 36. Try C on your own. A quality control inspector checks for defective parts. The table shows the results of the inspector's work. So he inspects a bunch of parts. There are some that eventually are found to be defective. Of the parts that are found to be defective, 5 of them passed his inspection, 24 of them failed his inspection. Of the parts that ended up being non-defective, 208 passed his inspection, 9 of them failed his inspection. Find the probability that a defective part passes. So defective pass is 5, but what goes on the bottom part of the fraction? You have to think about a column that doesn't exist here. There were 29 total parts that were found to be defective. So 5 out of 29.